Good morning, good afternoon, everyone. Welcome and thank you for joining this webcast. My name is Fabrice Buron. I'm CCO at INT, and I will be your host during this event. Let me start with a few housekeeping items. This presentation is both live and interactive, so you can ask questions at any time via the Ask a Question box in the presentation window. We will answer as many of these questions as we are able during the Q&A portion that will be at the end of the webinar. We've got a copy of the slides presentation that has been made available, and you may download that as well as any other resources provided from the Event Resource tab, just under the Ask a Question box. If you have any technical difficulties during the webinar, just type your issue into the Ask a Question box, and a member of our team will assist you. If you are running pop-up blocking software, you will need to disable it to view the webinar. In addition, it's recommended that you close down all other applications for better performance. For your convenience, this presentation will be available on demand viewing within 24 hours of this live event, and a follow-up email will be sent to all registrants containing a link to the presentation for on-demand viewing. Now let's talk about what we will cover today. The oil and gas industry is going through rapid digital transformation, first by moving to the cloud, second by adopting standards like OSDU to enable systems to talk to each other, and third by automating processes with machine learning. This is obviously a very hot topic, and today we'll be discussing how to simplify the geoscience machine learning end-to-end workflow. And now it's my pleasure to introduce Sasha Sario-Glo from INT and Dimitri Tishevkin from AWS, who will cover this presentation. Sasha, I will now pass you the mic to present, and you will have to share your screen in a second.
Oh, hello everyone. Can you see the presentation? Can I start?
Not yet.
Okay. Okay. Hello everyone, and welcome to this talk. Today we're going to discuss the integration of machine learning into geoscience workflows. Fabrice, thank you for presenting. My name is Sasha Sario-Glo. Official name is Alexander, but we can leave that to a different discussion. Today we're going to go on a high level. We're going to discuss what issues exploration and production is facing when integrating machine learning workflows. We will introduce you to IVAP, a product which has been developed by INT and which I'm a part of as well. We will show you how IVAP is targeting and addressing those issues for machine learning integration. Then Dimitri is going to go over the SageMaker, the AWS SageMaker, and discuss how SageMaker acts as a powerhouse to power all of this integration. Then we will show you a quick demo from how all of this comes together. And this demo will be represented from the IVAP standpoint. You will see how user actually interacts with all of these systems. So first we need to understand where the problem is before we jump to solutions. A little hint, a lot of problems are arising with data. I will be saying data a lot today. I'll try to switch between pronunciations so I don't offend anyone. So how big is this issue? Well, it's about 66% according to one of the websites. You can follow up with the Anaconda website to see where the data is coming from. But a big chunk of work of developing a machine learning model actually comes from finding the right data, cleaning data, organizing, putting it together, labeling, to train the models and everything. This issue is so big that sometimes it can take over your entire project and actually run you out of your budget even before you get to machine learning aspect of it and before you develop the models. So naturally, the question is, why is data taking such a big part of the workflow? To name a couple of issues here, and these are all specific to exploration and production, although they can show up in other industries as well. First of all, data is very distributed. We have to collect across different environments, different data storages to identify those data objects. And it doesn't help that majority of data that's used in exploration and production is very, very big. For example, your seismic data sets can be tens, hundreds terabytes in size, and they're monoliths. They only make sense as a single piece. So all of these moving and sharing and understanding the data takes a lot of time. And it also doesn't help that data comes from different vendors. There are multiple formats, multiple ways to record. Some of them recorded one way, some of them opposite way. So cleaning and making data uniform so that machine learning can be trained and can understand this data is a big issue. So again, why do we have this big data problem? Is because data is the core concept of machine learning. Machine learning is all about data. In every step of the process, be it development or operations of a model, data is used in one or another way. First, we find, collect, organize, clean data for development. Then we split it and label it for training. Then we use another part of it to evaluate the model to understand whether it's working properly or not. And that's only the development side. We go into operations and that model becomes available. Now we're feeding data to it. And guess what? Output of a model is also data. Now we have to look at that as well. So it's very natural that data is a big bottleneck here, but it's not the only bottleneck. As in every software application, we have issues going from development all the way to production and displaying value on the user's screen. The value flow from the R&D and all the way to the operations is usually very slow. The continuous integration and the deployment pipelines are coming aboard. They're already they're advancing every day, but there is still these gaps in application integration for the models. And here, I went over things in a very generic form, but I promised you key points of key pain points. So here is 4 of the pain points I identified specifically. I talked about all of them before. First, data quality, collecting, organizing. Then once we have the data, we develop those machine learning functions, but those functions are very hard to expose to the user, to someone who will actually gain value out of these functions. So this brings us to the part where from research and development moving into operations takes quite a bit of time and effort. So how do we streamline this? How do we bring this into the modern agile workflow with the constant feedback? Speaking of feedback, output of your data model when it's in production is also very important. You're doing this for a reason. So feeding this output back to the same system that the user is running the model so that they don't have to switch between multiple sophisticated environments is another big issue. So here, let me invite you to take a look at IVAP. It's a product which I've been working on as well. So it's a tool that we developed at IMT. I will give you a high-level introduction, and then we will look at how IVAP approaches solving this problem. First, this slide I can read right away. This is essentially what IVAP tries to do. Is a new way to connect the dots, a single place, keyword single place, for data exploration and ML execution. So for a user, they are logging into the same environment. Every workflow end-to-end from picking data and visualizing output happens within the same place. Here at INT, we try to do all of the heavy loading. So to a user, the workflow looks as simple as this slide. To go through the workflow real quick, someone would log into a place, log into a website or an application, which is IWAP, search for data. Data would come from different places into the same application. You can have databases, files, all of those can be connected together. Then preview that data, co-visualize in the same place, and identify data of interest. Then select what you need. Then select model, which comes from the integration with machine learning services and other services as well. Those models require some kind of parameters defined by them as well, and user can select those parameters, run the model, and get notified when data is showing back up into their system, and repeat the whole process again. So this is what our end goal is. This is what we call the end-to-end integration. So what is IWAP itself? It is a platform. We have multiple components that come together to deliver a single value proposition. So one part is data visualization, which usually happens on the client side, although we have some server-side rendering as well. But there is these visualization tools that are catered to different exploration and production data types and workflows that you can use within the same place. Then we have the data integration part, which is another part of the platform which provides these pluggable integration points for different data sources. And both visualization and data integration come together to integrate machine learning workflows, because machine learning workflows are sophisticated and require both parts of the equation here. To dive a little bit deeper into the integration aspect of this, most of the communication with external data sources, let's say databases, streams, files, and management systems, is happening through IWAP backend. IWAP backend in itself is also a platform and contains multiple components. Those components are decorated as microservices. So this is a microservice architecture where services can be plugged and unplugged at will. Some of those services provide the layer functionality. Other services provide more specific functionality to the data and create the data APIs. Example for the overarching layer functionality would be events and messaging and security and authentication. Those cater to all of the components of IWAP. And then we have those data integration services connectors. And those connectors are more detailed to specific data they're working with. Let's say we want to read from PVDM, we have a connector for that. We want to parse SIGY, we have a connector for that. Then this helps us abstract the complexity of the data storage from the client and from the user. What happens is IWAP backend takes on all of that work and then has a simple way to communicate this data to IWAP, an IWAP client, a uniform protocol which is used between backend and frontend, and IWAP client then takes this data, puts them into nice views, and presents them to the user to be used. So speaking of these data sources, one of the examples of such a data source is OSDU. And OSDU in itself is a platform, but for IWAP, it's another data source. We have connectors which integrate with the OSDU data platform services. They have the data API from there, the way we can read, we can write if necessary. Then the IWAP client then provides the user a way to ingest those functionalities to look at the data from OSDU, but as well as use the application services from OSDU, like, for example, search. So I won't spend too much time here, but we have been with OSDU since day one, and we've been evolving together with OSDU. So IVAP is probably fully integrated with this platform. So now that you've seen some of the key components of our platform, let's talk about how this all comes together to deliver an end-to-end machine learning workflow. To the user, this all looks very simple. User logs into an application, searches. He's provided tools to search and discover data, be it on a map or be it from a connector. The user would search, put the data into some visuals, look at it real quick in the same place. Once data of interest has been identified, they can select the data they want and organize them into projects. Then the machine learning service, it can be an external service. Most of the time it's going to be an external service, can integrate with IVAP, and the option to choose a service will be displayed to the user. They will then specify outputs which are defined by the service itself and run the service. Then user just sits back and waits until data comes, a notification shows up that the model has run and data has been added back into their project, and they will be able to visualize it without ever closing the application. To deliver this end-to-end workflow, a couple components come to play. One of them you have already seen, the data connectors. These have been around for a while. Something that we released in the latest release 2.8 is the two key components that enable the end-to-end functionality. It is the messaging layer, which allows these services and machine learning workflows to send notifications back to the user through the IVAP system. And then we have this dynamic UI generation, which allows us to plug services and unplug services from the client without having to rewrite, rebuild, redeploy all of these applications. So it's really working on the fly. You can even close and open a dialog. If service evolved within that time, the dialog will reflect that. And of course, the connectors provide a way to read data, bring them into IVAP, use all of the normalization and all of the cleaning functionality, and then deliver it to your workflows, as well as write output of your workflows back to some kind of storage. Now I understand that dynamic UI is a little bit ambiguous, so I'll go a little bit in depth in here. What we have developed is a set of functionalities which are formed on top of a spec which is called JSON Forms. JSON Forms is a widely known specification to define forms and dialogues as a JSON schema. JSON is a JavaScript object notation. It's widely used for web development. The JSON schema itself is an internet standard, is an IETF standard. So there's going to be no surprises there. Then this implementation of the spec takes that schema, and the schema defines a couple of things. It defines the structure of parameters, what they are, what type they are. It defines the layout for your user interface. You can group controls. You can arrange how they look, how they are semantically separated. And then another one, which is our additional functionality on top of the spec, is that a service can define the output. So we provide this library of controls, and we in the documentation you can see what output every control generates, and by specifying a transformer, a template for the transformation, we can deliver the properties to the service the way service is expecting them. So going back to the library of controls a little bit, what is really powerful here is that we provide out of the box a pre-developed set of controls which know how to work with IVAP data model. For example, on your screen, you see a curve selection control. All that the service is specifying is that it's a curve selector. Everything else is taken care by IVAP. It creates this curves control, which enables you to select to pick which wells you're choosing or pick an entire group of wells. Then it will let you pick the well logs of interest and in the end to specify your curves. And even if you need to convert your curves into some kind of a unit to normalize your unit, you can also provide that. We will see how this all works together in the demo in the end, so hopefully it will clear it out a little bit more for you. With that said, the dynamic UI is only a small fraction of IVAP functionality. There are tools in the client which enable and empower user in every part of the machine learning model lifecycle. We have tools that help the user select and search the data. We have tools that help preview and adjust and clean up the data. We can feed it back to the model the way the user wants it. Evaluation, we can overlay the data on top of each other. We can compare. We can co-visualize different data types and multiple data types of the same type together. And of course, for deployed models, we can use the workflow I described earlier, where we can select and deliver and visualize the output. Where some of these I will show you in the demo. So just hang tight. Now that we know all of these components, where can this be used? And the uses are really endless. This is where I encourage everyone to give freedom to their imagination. Some of the uses that we've already seen, and I can talk about is, for example, for well data, we could classify facies. We can predict some curves based on other curves. We can predict porosity, density. For seismic interpretation, we can pick faults. We can identify bodies in the seismic data set, and we can identify sweet spots and things like that. So really, as long as you have the right data and the will to explore, machine learning provides freedom to your imagination. With this said, I will conclude introduction into how IVAP solves this problem. And yes, we address data and we address all of the workflow issues, but there is another part of machine learning where the whole process of development and delivery and deployment of those functionalities it also takes a lot of time and knowledge. So this is where AWS and AWS SageMaker steps in and really acts like a big powerhouse to empower all of those lifecycle steps for a machine learning model. This is where Dmitry is going to give you a deeper dive into how AWS achieves this. And Dmitry,
I'm ready.
The floor is yours. Thank you everyone for listening. I will see you again when I'm doing the demo. Thank you.
Okay. Hello all, and thank you, Sasha. It is always great to collaborate with you and INT, and I'm excited to present how AWS enabled IVAP to provide the cohesive machine learning workflow. We know machine learning by itself is hard, and today is a little bit disjointed. So I will give you an overview of AWS full machine learning stack, and at each layer of the stack, we're removing undifferentiated heavy lifting, so your teams can move faster. And at the top layer, you see our AI services, which allow developers to easily add intelligence to any application without need for any ML skills like computer vision, speech, text to speech, and so on. And at the bottom, you see the expert practitioner tools where experts can develop on the frameworks of their choice as a managed experience in the AWS cloud infrastructure, which is fully configured with framework and tools. And right in the middle between these, that's where Amazon SageMaker sits. It provides the developer and a data scientist with the ability to build, train, and deploy machine learning models and scale. So it looks like a full life cycle for it. It removes complexity from each of the steps, and SageMaker is at the heart of IVAP ML workflow as well. So I'm going to tell you how IVAP and SageMaker combined will help you to make a product out of your research and development machine learning. So SageMaker has many features, as you can see on the slide, and you feel free to explore them afterwards. And I will only talk about features that are most useful and applicable to the development, deployment, and operation in the artificial intelligence and ML. These features include managed notebooks, training, and deployment, and cost savings for training and operations, and very important, ML operations, or also known as ML ops, a very important piece that's usually not taken into account when working in-house on machine learning. So first, you really need to develop your model, right? And that's where your R&D workflow starts. We have a SageMaker Studio. It's a visual integrated development environment, IDE, right, for the complete ML workflow. It unifies all the tools for the machine learning development. So as a developer or a data scientist, you can write code and track your experiments, visualize the data, perform debugging and monitoring, and everything inside a single visual interface, which will significantly boost productivity. The SageMaker Studio components provide extensibility for integration. So, for example, IVAP uses it to prepare the environment with data from OSDU or any other data platform. So here's an example of what SageMaker Studio looks like in real life. And in this example, we are in a managed Jupyter notebook. We are using it to develop a machine learning model for well logs interpretation and formation prediction. But it could be any model here for seismic, for example, for horizons prediction or for production optimization. So the important part is where you develop the model, and it's usually a Jupyter notebook. So Jupyter notebook is an integral part of any machine learning development and a component of a SageMaker Studio. It's where data scientists spend most of their time after the data is ready. So managed Jupyter notebooks offer integration interface as well, where they can be created automatically within the second from the other platform like IVAP, right? So IVAP, for example, can request it from the user interface. And this integration allows seamless and no interruption workflow from the visualization to the development, where you build the model in the notebook, and then you see a result in IVAP, and your data comes from OSDU. So all three pieces are coming together, right? So the way it works, you select data in IVAP, and it will prepare the data environment and make sure you can start developing right away without spending much time on searching and collecting the data. So Also, important part, managed Jupyter notebooks are ready for corporate IT security. They support single sign-on, and underlying in infrastructure is fully elastic. So if you need to add or remove power when you need it, and all changes you make are taking place in the background, so there's no interruptions to this. And when you need to work with the colleagues, or even if they're remote, right, you can easily share a notebook with any team member or members for no limit collaborations on any tough problems. And with sharing, all the code dependencies will be transferred as well and automatically captured. So the team member can see exactly the same notebook and repeat exact same steps in very quickly. Okay, so the ML development is usually very similar on a high level to how software development is done, but it has its own challenges, right? And you see, just like in software development, the successful commercialization and productization of this machine learning project requires automation in the development and operation workflow, right? Machine learning comprises of multiple steps, some of which take place in sequence, some are in parallel. And there is a lot goes into stitching those workflows together. As in traditional software development, like continuous integration, continuous deployment pipelines are used to automate deployment of workflows and keep them updated. And this CI/CD pipelines reduce errors and provide feedback loops to enable fast iteration, and which plays a key role for reducing your time to market. In machine learning, on the other side, this CI/CD style of tools are rarely used because they either don't exist, or where they do exist, they are super hard to set up, configure, and manage. And to set them up, you would need to create a standardized code recipes for the data preparation, model training, model deployment, and then combine them together into workflow so they execute as a single automated sequence of steps. And let's see the steps, right? First, you need to package your code and recipes, and then define the order in which they need to execute, keeping track of code data and model parameter dependencies between each steps. Then, after the models are deployed, you need to write code to continuously monitor models and data in production, because the changes in real-time data can cause the model to make inaccurate prediction, for example. And if problem is detected, well, you need to write more code to retrain the model, take the model out of production, and slow down your business because of that. And many model builders and data scientists don't have time or experience to create those CI/CD pipelines, so they rely on manual handoffs between the teams, right, which is slow and error-prone. So SageMaker offers pipelines, which is a solution to all of the problems I just listed. The machine learning CI/CD service accessible to every developer and a data scientist. The pipelines will reduce the months of coding required to manually stitch together different code packages to just a few hours. And with a few clicks, you can create those automated learning workflows. The pipelines will take care of all heavy lifting involved with managing the dependencies between each step of the workflow and orchestrate them so you can scale even to thousands of models in production, and then you can expand your machine learning across more lines of your business easily. Pipelines provide comprehensive steps, including algorithm setup, debugging, optimization, and many, many, many more. They also, which is very, very important, keep track of every step of what happened in the past, and you can rerun those workflows at any time. So this provides repeatability and reuse, which is very important to share inside your organization if you want to start sharing these practices, right? And you can start making improvements into your models, into your algorithms, and your optimizations. So the important piece is to get you started quickly. We included pre-configured template, right? So you don't have to start from scratch. There are pre-configured templates for model building, for deployment, and these templates are fully customizable so that they're open. You can continue building on top of those. Okay? And once created, these workflows can also be visualized and managed in a SageMaker Studio. So, for example, you can compare model performance from version 1 to version 1.1 and see which one is better and deploy the best model for your use case. And that's an example of it. It's a screenshot where you see a model in a model registry. This also have a Python SDK where applications like IVAP platform can integrate, and you can do it in the platform of your choice. And the next one is another example of managing machine learning approvals for release to production, similar to how you approve your software, right? Going from the release to production. Same here. Data scientists or managers can approve going models through every stage of CI/CD pipeline, either manually or automatically. So the next step is to train your model. And to train, you need to specify the location of your data, which is prepared by IVAP, and then you indicate the type and quantity of compute resources that you need, and you get started with a single quick click. And as training starts, SageMaker will set up a distributed compute cluster to perform the training. So it's very similar to high performance computing. And then after training is completed, it will output results to Amazon S3. And Amazon S3 is the object storage service. And then cluster will be automatically shut down for you. So SageMaker will take your algorithm and run it in isolated cluster and will auto-scale as needed according to the parameters you provide. So it streams data from S3 very efficiently, and depending on algorithm, it will be either sent to each node in the cluster or distributed across all the nodes. So this provides a great possibility to dramatically reduce the time and cost of training runs, because you usually need to do many of them to come up with a viable model. All right. And algorithms. Algorithms are very important. Each model requires its own algorithms. So SageMaker comes with dozens of pre-built algorithms already and optimized. Supervised algorithms such as XGBoost or linear regression or classification to address recommendation and time series prediction problem, for example. Also, we included support for unsupervised learning, such as the k-means clustering and principal component analysis. And of course, if you don't want any of this, you can bring your own algorithm. Nothing stops you from that. So more on training, we offer spot training, and what is spot? I'll explain. Spot instances let you take advantage of unused compute capacity in the AWS cloud, right? Spot instances are available at up to 90% discount compared to on-demand prices. So when you need them, this translates to very cost-efficient training. And I think it's very important if you do multiple training jobs. So this approach is ideal if your training schedule is flexible Uh, SageMaker will manage provisioning of the Spot fleet instances and will manage interruptions. And training jobs will pause or resume reliably as the Spot capacity available or not. So built-in frameworks and algorithms will also checkpoint automatically for computer vision algorithms. And other support for other algorithms is coming pretty soon. So once you train, you want to deploy your model, right? And you can deploy your trained models, or you can deploy custom-built models. And yes, I mean, SageMaker will deploy models that are built outside of SageMaker, right? So you're flexible in any part of your machine learning journey. This feature is useful if you want to realize deployment capabilities of SageMaker, but not yet ready to move your full machine learning development. And model deployment, of course, is fully scriptable and can be automated with AWS or third-party tools. So, and deployment supports two hosting models called batch and real-time. A batch offers high throughput when you need to run inference for the large data sets. And ML inference is when you ask a model to make a prediction. So, and with real-time deployment, what you get is a low latency response for the single inference or multiple inference at the same time. So all deployments are on fully managed infrastructure, which means it takes care of IT infrastructure setup, management, patching, and updates. So I want to continue and explain more on what is a batch and what is a real-time hosting. So when you deploy the pipeline model, SageMaker installs and runs a model in the containers on Amazon Elastic Compute Cloud or EC2 instances. Depending on the mode chosen, it will create an endpoint or a transform job. So real-time model is an always on and exposed to the application as a long-running microservice with a REST APIs. And a real-time hosting model will respond almost instantly for the small data batches that arrive in frequently. Batch transform, on the other side, isn't optimized for the large data sets and data sets that require pre-processing, such as like removing noise or bias. And with batch transform, you can run inference without persistent endpoint at all, which leads to cost savings. Right? So you only pay for the inferences that you use. And continuing on inferences, we understand that you need to run your business globally, right? So you can host your inference around the world. So today, SageMaker supports 18 AWS regions and flexible access patterns provide ability to integrate model into the application. And for example, work we have done with INT together, you can quickly build and publish a model and integrate it with ease into IVAP. And with a few lines of configuration, as you've seen, no coding required. And models can be accessed from the popular frameworks. And monitoring is a very important part of the operations. In production, your DevOps team will need to maintain reliability, availability, and performance of machine learning models. All the real-time endpoints and batch transform provide metrics and logs integrated into Amazon CloudWatch. It's a monitoring and observability service built for DevOps engineers, developers, and site reliability engineers, and IT managers, right? You can monitor AWS Cloud resources used for inference in real time using different metrics like number of invocations, error rates, model latency, model load time, and so on. And for security and compliance, SageMaker integrated with CloudTrail, a service that enables governance, compliance, and operational and risk auditing. So CloudTrail will capture a service and who made the operations with them. So after you deploy the model, you need an ongoing support and maintenance, right? That becomes a priority, and that's where DevOps or SRE team take over. So there are several things to ensure that these teams can successfully accomplish operating model in production, like model registry, the managed CI/CD pipelines, the model updates, and optimized compute resources. For example, model registry keeps track of the model versions in the registry. So it tracks and compares models and evaluation metrics for each one. Managed CI/CD, I already explained, provide managed ML ops. Seamless model update, provide way to update a model version in production without interruption. Just like in the modern software development world, there are two main patterns for rolling out to production, blue-green and a canary deployment option. And these processes have proven themselves over time. Exactly same approach is used here, but with machine learning. So you get to reuse the same processes. And optimized compute, use optimal resources that are best fit for the model. For example, prediction algorithm that requires high memory will use memory optimized instances. And if model works best with GPU, it will use an inference optimized GPU instance. So, and diving a little even deeper on the operations, you can auto-scale your operations based on different patterns, such as traffic coming into a model or CPU or GPU utilization with a set of min and max criteria. You can run different production variants of the model, similar to what A/B testing is called. Use inference pipeline for stitching multiple models together, because in real life you usually run 5 to 7 models sequentially to get a good prediction. And then you can also host multiple models on a single endpoint, which will allow additional cost savings, where a single HTTP endpoint can call to multiple models, right? And a model monitor who will collect operational data and initiate alarms that's needed. So I think with that, you can certainly build, deploy, integrate, and operate a machine learning model like a pro with IVAP and SageMaker. And this is all I had today. And Sasha now will demonstrate some of the capabilities we talked about. Thank you.
Sasha,
yes, okay, good. So here is a pre-recorded demo that I recorded earlier about how this all integration end-to-end looks from the IVAP standpoint. Think about this as how a user is going to see your machine learning workflows and utilize them. So let's just dive in. Here you can see an IVAP, and we're going to open a project. This implies that I've already found and organized the data that's useful to me. So the whole search is kind of skipped in this demo. Here you see that we're loading a well into a well log view, a well log. The well which is there right now contains a GR curve. However, there is one well that well log that we have which doesn't have a GR curve, and we would like to predict that. We want to generate a GR curve based on curves from other data. Here we have a machine learning model which runs in the background. There's a service which runs a machine learning model in SageMaker, which knows how to generate, how to predict curves based on curves from wells which already have GR. What we are doing in here, you see a dialog which was automatically generated. The demo will show you how that worked out. Here we're choosing some wells. This is the model building, and the model is going to develop itself in the runtime, meaning that it will look at the wells, at the logs which have the GR curve, and use them as the training data, and then logs which don't have the GR curve will be the GR for those who's going to be generated. So in this scenario, we have two wells, and we're going to select what reference curves we want to use for prediction. We can also select units if we wanted to convert, but we don't want to convert in this example. Then we can put an output name for the log output. This model is going to output into an LAS file that we're working on integrating with the OSDU data management systems as well, so we can write back to the log. Right now, we're going to generate a new log. What I'm showing here is the part where we talked about schema. This is the schema retrieved from the service. It defines the elements, what inputs it's expecting, as well as how the things are laid out. So you can see service is running. It's identifying the training data and sending notifications to the user. Notifications are showing up as the model continues running. You see it's trained, prediction done. Now we should be expecting data in our project. Without leaving this project, we go ahead and we identify that our predicted GR, log with the predicted GR, has been added back. We can just go ahead and throw it into our view and visualize it at the same time. You see that the data has been generated only for the part where NPHI has the data. I am assuming DT has the same range. That's why it's only that part. So this is a very simple use case. We have a simple dashboard. We just choose and run the model. Now I'm going to show a different dashboard with some more sophisticated data views. And we have another process that we developed here at INT. This is called the gridding process, gridding service, for a better word. This service takes a set of tops and generates a surface from them. It's another example of a machine learning where now we work with the different types of data. But here I talked about those user interface tools that we are presented to be able to manipulate and work with our data around the processes. So you see we have the gridding here, and I'm going to feed the top that process. However, let's assume I identified a top which is not exactly where I want it to be. And this is all demo data. Don't look at the fencing, the way the order in which I selected these tops is completely random. That's why it's all zigzagging all over the place. You can see me modifying this top to the place where I want. Now the truth that the backend and the client nodes have changed. So this is going to be presented to us. We need to save this top back to the data source. And now that we have this, we can go ahead and run the gridding process. So we select where the data is coming from. All of the controls that you see here for top selection, for data storage selection, all of these are pre-written, but they're provided out of the box by ILAP. All we had to do is, as you've seen before, just to provide a schema. So we select the connector. So that's S3. You see we just tell the process where we want the data to be output. It can output it anywhere, any connector, any supported writable connector. While that's running, I'm going to show you one of my favorite features. This is the ghosting. So ghosting tool helps us identify the location of stops a little bit better, or much better, I would say, or it helps us overlay two sections from two different data, from two different curves, logs over each other, and to do some evaluation maybe. As you can see, the model has run. We can go ahead and look at our data. You see the new the surface has been added. We can just go ahead and throw that surface into the 3D view and take a look at it, validate if the surface matches stops properly. As you see, we already had a surface in there. I'll go ahead and remove that previously added surface. so that we can look at our new data individually. You can see it follows the tops. So from what I see here, I can pretty much say that the model runs at least within a good error threshold. So yeah, this pretty much concludes my demo. You've seen the end-to-end integration from selecting data, running the model, and visualizing the model outputs.
Thank you, Sasha.
To conclude this, let me say a couple of words. And so, machine learning and the entire workflows are, as Fabrice said in the beginning, are pretty new to the industry, and we still are having difficulties identifying how to run the CI/CD, how to integrate research with extracting value at the user's end. And IVAP is tackling these problems continuously, has been tackling these problems for a long time, and together with a powerhouse like the SageMaker is, now to us, the scientists and engineers, this is finally something that's achievable, something that we can see a clear roadmap to, and I'm happy to be able to present this to you and be a part of this. Thank you everyone for listening. This concludes my presentation.
Thank you, Sasha. Thank you, Dimitri. I really appreciate the efforts, and it's a lot to cover in 1 hour. We've got 3 minutes for Q&A. So before we begin the Q&A, if there's any questions we cannot address now, we will make sure to follow up individually. You can submit your question into the Q&A box on your console if you haven't already done so. Our first question is, I see this works with well data. Can you work with seismic data in the same way? So I think, Sasha, that's a question for you.
Yes, so the entire integration and workflow are not specific to data, they're more specific to the process. So any data that IVAP can consume in the data sources where you have connectors to can be integrated with the workflows like this. The workflow itself is an external process, and the integration, as long as the integration points are met, this will all work together.
Okay, thank you very much, Sasha. The next question that we have is this available as service or product?
So there are a couple parts to this. So from what I showed you from the IVAP side, the integrations and the mechanisms and the REST APIs that allow to communicate are available from IVAP as a product. I'm sure Dmitry will also chime in saying that SageMaker is definitely a service.
Yes.
Available.
Sure.
Yeah. Available
SageMaker
service.
Is a service. Yes, it's available as a service on the cloud. Once you have an AWS account, you can log in and start using it right away.
Yes, but the models themselves and training and development is it falls onto your shoulders to develop something that you can integrate with these systems. And SageMaker also provides a lot of that.
Very good. Thank you. The next question that we have is, are there limits to using a training job with a Spot instance?
Yeah, I'll take that, of course. Right. So yeah, you can provide various criteria of how you want to limit your job, especially with Spot, because Spot may be available, maybe not available for a while, and time is one of the critical things where you can set up your limit of how long it should take, right? And if it doesn't, it will automatically stop the job. So that's available.
All right, and because we're on top of the hour, I will cover the last question we have, and we'll have a few other questions we'll follow up after the event individually. So how specific is the workflow to the individual who creates it? In other words, is there an issue with one person leaving and another trying to pick up the project?
Again, I think there are two aspects to this. From the IVAP standpoint, we have users and we have user groups and entitlement system where you can share your projects with other users. The workflows and the services which you've seen in the UI that are integrated are available to more than one user if configured. And Dimitri will probably talk on the SageMaker side where,
Yes, I'll happily explain. Is a similar feature. We have a service called Identity and Account Manager, where you manage accounts for the users. And in the SageMaker, you can share your work with the other user. So just by selecting a user who you want to share with, and it will share all the training resources, dependencies, Jupyter notebooks and data with the other user or even group of users, so that it's definitely ready for the team collaboration.
All right. Well, thank you very much. So it's 11:02. So unfortunately, we'll follow up with all the questions that are remaining one-on-one. Thank you again, Dimitri, and thank you also, Sasha, for this great presentation. Thank you to our sponsor here, so AWS, NINT, and Endeavor Business Media. We would like to thank our sponsors, and we'll wish you a great rest of the day. Thank you so much.